Okay, so number 9 on the practice problems on particle kinematics. So that's the one where you have rolling without slipping of that wheel. So here's your bike. Thanks. Wipe out. And it's moving with a constant speed of 8.8 meters per second. How fast is that in miles per hour? Yeah, right, about twice that, something like that. So pretty fast. And the wheel has a radius of 0.34 meters. And it says, so this is really the definition of rolling without slipping. The point of the wheel that's touching the ground is always moving the same speed as the ground, right? If they're not moving the same speed, it's slipping, okay? So how fast is the ground moving? 0. So the point touching the ground always has to have 0 speed, okay? And if it has 0 speed, velocity is speed in a direction, so it also has 0 velocity. So we have to figure out a few things about the motion of the wheel. We're going to use this fact that at this point where the wheel's touching the ground, the velocity is 0. And basically what we need to do is figure out what the angular velocity of the wheel is based on what we know about the motion of the center of the wheel, okay? And based on the fact that we know that the bottom has 0 velocity, and then we'll use that angular velocity for all of the calculations that follow. All right, so we know that the velocity of the center of the wheel, so it gives you the speed of the bike. The speed of the bike is the same as the speed of the axle. Okay, that's kind of the way to think through any of these problems where you have a circular motion superimposed on top of some other motion. Okay, so the velocity of the center relative to the ground is equal to, well, we need to choose a coordinate system. Let's just choose this standard one like this. So the velocity of the center relative to the ground is 8.80.